Page 71, we're going to be reviewing lessons 1.5 through 1.9. So we're just going to pick out a few of these problems to look at, make sure we understand what's going on here. So starting out with number 59, we're adding these together. We're not going to be using calculators for these, so make sure we understand what's happening. 59, we've got a negative and a positive being added together, so they're kind of working against each other here. So we're going to subtract those. If you subtract, you get 1 8/10, and then the question is whether we have more positives or negatives. In this case, we have more positives, so our answer would be 1 8/10. Number 60, we got to be careful on this one. That negative out in front, we just bring that down. 12 squared means 12 times 12. 12 times 12 is 144. The negative just comes down with it, and our answer is negative 144. And that's different than if we would have had negative 12 in parentheses. That would have said negative 12 times negative 12, which would have been a positive 144. Um, 61, we are just multiplying here. Negative times negative would be a positive, so that would be a positive 40. Number 64. Anytime with these subtraction problems, you can add the opposite if you want. Make your two sign changes in the middle. And that would end up being then a positive 3. Two other problems we're going to look at here that are not in your book. So one is if we have a square root that's a fraction. So let's say we've got plus or minus square root of 9 over 100. Anytime if you have a square root in a fraction, you can actually split up as the square root of the numerator and the square root of the denominator. So if we do that, take the square roots of each of those separately, and then we should end up with plus or minus 3/10. Another problem they're not mentioning right here, but we could see is dividing with fractions. So 4/5 divided by negative 2/7. Dividing, keep, change reciprocal. Usually I'll put the negative up with the numerator. If you keep it next to the 2, that's okay also. And multiply that out. You get negative 28/10. That's negative 2 8/10, which reduces to negative 2 4/5. If you had it as negative 14/5, that would be okay also. Lesson 7 is on the distributive property. So if you have a number next to a set of parentheses and they're adding or subtracting in the parentheses, you can use that distributive property. So it's multiplying into the things in the parentheses. 76, if you want to add the opposite there before you get started, you can. And then we'll multiply the negative 2 into both of those. Over here then, negative times negative would be a positive, so negative 14 plus 2a. Same idea if we look at number 80. On 80, I would suggest rearranging this, bringing that 1/4 out in front. And then we can distribute. If you want to add the opposite here, you can. It's not quite as big of a deal since our number we're distributing isn't negative. The number on the outside isn't negative, but if you want to do that, you can. So that'd be 6/4 y minus 1/4. And then we can just reduce that down. If you want to change it to a mixed number, you can, but you can just leave it like that otherwise. One other problem we're going to look at here that was not in your book is if we just have a negative outside the parentheses. If you want, you can add a 1 in front of that. Once again, if you want to add the opposite here, you can. Negative times negative is a positive, so negative 1x plus 2 or if you just had negative x plus 2 would be okay for that one. And almost missed this one, number 86. It's asking if those are like terms. The deal is all the stuff's being multiplied together so we can rearrange things. And so they would be like terms because they both have essentially an x squared y part. The variable part's identical, then they're like terms. Lesson 8, we're seeing whether these are solutions or not. So we are just substituting in the one number they're giving us and seeing if it works or not. When we do this, we need to remember our order of operations. So exponents is going to come before multiplication. And if you do this, you'll get negative 27. That's not equal to 27, so the answer would be no for that one. If we go to number 92, they are saying they want us to use a table to find or estimate the solution. So if we do this, if they ask us to do that, then I guess we need to do that. So we're just going to guess some numbers. So we want our value to be 24. So we'll just try some different numbers. So let's say if we put a 10 in place of m. That'd be 30 minus 14, that'd be 16. We want 24. One thing we can do is we can see the m is being multiplied by 3, so we're going to go up by 3 every time. We're off by 8. So if we went up 3 threes, that would be 9, would be just too much. So I'm going to go up 2, which should put me up by 6 more than what I had. So that would be 36 minus 14, which would be 22. And then if we go up one more, that'd be 39 minus 14, which is 25. So we can see it's right in between there. So we could say it's between 12 and 13. It's going to be a little bit closer to 13 here, but it would be in between those two numbers. Look at number 96. They're asking whether the given ordered pair is a solution of the equation. So in this case, we actually have two variables. And the thing we got to watch for is making sure that we substitute in for the right thing. So probably be a good idea just go ahead and mark that as x and y before we do the substituting here. So 0 in place of the y, negative 6 in place of the x. And then we're going to see if this works or not. So if we work this out, we'll get 0 equals 6. 0 is not equal to 6, so no, that's not going to work. I think if you actually switch those around, if you put the x and y in the wrong spots, then it actually does work. So again, you got to be really careful on that. And I'll be watching your work there also to make sure that you did that all correctly as well. If we look at number 99, I want us to describe the pattern using words, an equation, and a graph, and extend the pattern for x equals 5, 6, and 7. So we can just try to look at this and see what's happening here. And what you might notice is that these are going up by 10 every time. So if we extend this for 5, 6, and 7, we would have 5, 55, 665, 775. So that would be extending the table, and then we could think about it in words. So kind of on this one that's going up by 10. That doesn't quite get us exactly an equation for that though. It goes up 10 for every 1 here. So our slope is 10, so it's kind of like y equals 10x. That doesn't quite give me the numbers that I want, so we're going to have to adjust that a little bit. So if I put a 1 in place of the x, 10 times 1 is 10. I want it to be 15. So how do I get from 10 to 15? Is by adding 5. And then we can double check that with the other ones and make sure that it works. And it does. So that would actually be our equation there. So kind of again, a starting point is figuring out based off of your slope. And then this is kind of our adjustment that we need to make in order to get that to work. So once we have that equation, then we could say in words, we could say y is 10 times x plus 5 or something like that. So we've got a words equation, extended the pattern. We need to still do a graph though. So at this point we can make a graph. So we just graph some of these points here. We got like a 1, 15. Probably we're going to go by different numbers than what this graph's going by. So if we want to just go by 5s here. So 1, 15, 2, 25, these points aren't here, sorry, I just moved the screen and it moved them, 3, 35, and so on. And then what should happen here is our points should line up. We should have a straight line. And we don't know really what's going on here, so we're going to assume we can continue outside of the first quadrant. Some real life problems, only positive answers make sense, but we're going to assume we can have negatives here as well. Look on the next page, 73, number 13. The T teams in a soccer league, each team has 11 players. Make a table, write an equation, and draw a graph to describe the total number of players P in the league, and then how many players are on 17 teams. So if we want to start by making a table, so we got our teams and our players. So one team would have 11 players, 2 teams would have 22 players, and so on. And if we get 3 or 4 of these, that's probably good enough. So that's our table. Write an equation. So the players would be 11 times the number of teams. Take your number of teams times 11. That tells you how many players you got. So that'd be our equation. And then we're going to draw a graph. Before I forget, though, let's go ahead and do this. How many players are on 17 teams? You can extend the graph if you want. Otherwise, you can just multiply that out, and you'd get 187 players. And again, when you go to graph this, if you want for your graph, you can just, since we're going by 11s anyway, you can just make your graph go by 11s. Would be fine. So again, if we just want to ignore these numbers here, we can just go by 11s. So one team has 11 people, 2 has 22, 3 has 33, and so on. Now in this case, really you could argue for just having dots on this one, and then, I mean, we could kind of have a dotted line here, but we're going to assume we just have whole teams. We're not going to have like 5 1/3 teams or something like that. So probably we're just these, actually where these dots are would be the answers that would make sense. The other parts in between there, we would really not worry about continuing our line because in between points don't really make sense in this case. If we look at number 21, we're trying to find the error here. And so if we look at this, exponents should really come first, and then multiplication. The problem is here they did the addition before they did the division. So they should have done the division next. And then gone from there. And anyway, if you work that out all the way, then you should get, if you want to change this to a decimal, I guess we can. And then if you work that out, you get -8 25/100ths, or -8 1/4. If you kept it as an improper fraction, would be -33/4. So this should give you an idea what we're looking at on lessons 1, 5 through 1, 9.